Today we're going to have an introduction to a function generator and an oscilloscope. These are highly interactive tools, so it's hard to draw kind of like a static lab manual. Alright, so we have our function generator and it's just turned on, and we have our oscilloscope, and this is what it should roughly look like when you turn it on. I have two probes and both of the positive side and the positive side of the function generator just connected to a wire, happen to have a resistor around, and all the grounds are connected to the same. Alright, so it just starts up in 1 kilohertz, and we'll do output. Now it's on, and now we can see our waveforms. So looks a little bit blurry. Won't go into it right now. This is just more intuitive how to get things to work. But if you click acquire, alright, then down here there's something called mode sample, and you can see the different ways to sample things. You can do peak detect by clicking here, and notice there's all these little noisy things, and so it's detecting those peaks, right? High res filters that out. Envelope, I need to look that up. And then we have something called average, right, which will average out how this waveform appears. And so what you have to understand that it's reading from here to here every cycle, and so it's averaging that out. If you were to watch these waveforms, they would just continue on forever, but the display is going over and over the same period sample window, right? If you want to see this a little bit more, what happens, we just go to run stop. Okay, doesn't look like anything has changed because the average is averaging out things. So we'll go back to sample. All right, now we'll do, so now it's stopped, and we'll do a single. All right, so that's captured some data, and now if I zoom in and out on the time axis, you can see that data has been there for a while. You can see how much it's measured. All right, and we can go and let's take 5 million points and do another single. All right, and it's a little, the time axis is digitized better. It's not showing any more peaks. Let's try one more. All right, so it just goes for the waveform window, and I'm doing the scale here. So maybe I just haven't found it, but if you let it go in time, you should be able to see these sine waves just go on like a like one of those Richter scale things, right? But this just repeats every so often. So we'll go back. That takes data, so we'll go back to 10K, and then we'll run stop. All right, now I'm zoomed out. Right, my x-axis time is not as accurate. All right, and if you mess up, there's something called auto set. And it'll bring everything back. All right. So there are some measurements that we can take. We just click measure, right? And then down here, add measurement. That's the source. We can just try add snapshot all measurements. Sure. All right. And it tells you what the period was, duty cycle, all this information, right? So it just measures it quickly. You want to get out of that, just menu off. All right. Now, if I press this, up comes the wind, you know, all the things that you can say about that waveform. Click it again and it turns off, right? And then in here it tells you the time scale every large grid. Let me zoom the scale in and out, and you can see it change from 200 to 400. Okay, and then here is the y-axis scale. This is the scale voltage, and if I twist this button, you can see we zoom in and zoom out. And then this button here will raise and lower the waveform. Right here, that little dot, right, green triangle, is actually 0. All right. Now then there's one more thing we should cover right now, is triggering. And it's just better to show you when it's not triggering. And this will set the level. And I'm just going to be twisting that back and forth. You should see this green line appear. And now I'm going to move the green line out of the waveform. And now it doesn't know where to begin and end. So the way it knows to write over the same waveframe with the same period of the window is it's wherever that trigger is, right? It says that's the beginning of the waveform. And so it's looking for that point, right? And so if you don't intersect that waveform, right, it won't work. We can turn on signal 2, all right, and since it's the same signal, right, it should be triggered. I'm going to turn off channel 2, all right, and press the trigger menu, and it's saying that it's source 1, right? Even though source 1 is no longer on the screen, it's still triggering. But I'm going to just play with this trigger level until it stops working, right? And like I can't really find it because waveform 1 is missing. But I can click here and then rotate this knob. Oops. And now I'm on source 2, menu off. And now if I raise and lower this, I should be able to see it, although it is not working. So I'm just going to go auto set. Okay, still having a little trouble triggering. Let me go to the trigger menu. That's the level. There, now it's triggering properly. I'm just banging the table here. That happens. Okay, so we'll go back to auto set, menu off, and then I want both waveforms. Now, just one more thing. We can manipulate these signals mathematically. Now it'll be easier to see if we go to high res. Alright, and so now I'm just going to select math, right, and dual waveform math. Up comes the menu. So the first waveform, right, I click that, use this to rotate it to what I want, right? Because I'd been using it, it remembers it. Then waveform 2, right, I still use this button, I have 2. And then here I have the operator and I just cycle through. So that's the red line is them added together, and then here is the subtracting. Here's multiplication. And there is something a little weird, is that It's supposed to be the same signal, but you get a high peak, low peak, high, and that indicates there's some calibration issues. And we have divide. I think some things might not work so well in high res, so I'm going to go back to sample, then go back to math. I think subtract happens to be off, but that's another lesson for another day. Now I just want to get out of math. I just hit it twice and now there's no more math. There is one. I'm going to turn off channel 2 by clicking it twice, and then we'll do another math operation. FFT signal 1. I want to actually look at this in the linear scale. Alright, which looks like nothing is happening. Alright, I just see this little, and now I'm going to take more samples of the frequency, and now I start to see this vertical line, which is actually the magnitude, and now the red x-axis is now frequency. It's just too high to see. I have to use the scale factor. Okay, and now I'm seeing the amplitude. And yeah, the amplitude should be constant because, you know, we have a good supply function generator, but there is noise on the line. All right. Now, something you can see is that if I switch to a square wave, you can see all these harmonics of the classic 50% duty cycle square wave. I'm going to go to a ramp, and now you can see all of that. Now that can be kind of hard to see. So what you would rather have is the y-axis not in linear but in decibels. All right, and so now I'm going to go back to sine wave. All right, and I'm going to expand. Let's see if I can turn waveform 2 off. All right. So that still is one strong peak, but what can happen is you think you have a sine wave, and when you see other peaks there, it's part of total harmonic distortion. So that really is how to use the oscilloscope. This is time, this is voltage. These buttons here zoom in on voltage, zoom out on voltage, and move things up and down. Over here expands or zooms in on time, and then you have the trigger, making sure that the trigger is inside your repeating periodic waveform. All right. Now here's something interesting. Just while I was talking, there is a peak here that seems to kind of come up a little higher than you would think. So there could be, some, it's not a perfect sine wave. Or it could be noise. It seems to come and go. But that's enough for now.